So, the record and the lecture start. I don't put together the camera because I will not write or just write later on the board. So, we have 3 classes and we have 2 main topics that I want to discuss with you. The first is called singular value, singular vector, SVD-PCA. It is Hungarian. Why? Because there are 2 different syllables, one in Hungarian, one in English, and their content are different. But because I'm human and not a machine, I cannot prepare for 2 different lectures and practices. So I give the same presentation for you in English and the Hungarians in Hungarian. Today we will talk about singular value and singular vectors. This is far beyond your scope, absolutely, but it is in the topic and I have no clue what to do instead of this. Yes, and also there are programs. The programs is the following. Some part of some theory, statements and definition are missing to tell you properly this, so I will skip some part. Okay, so what is singular value? There were orthogonal matrices. We also did diagonalization. That's the orthogonal diagonalization. The orthogonal diagonalization is the diagonalization of orthogonal matrices. Orthogonal matrices are symmetric, and the eigenvalues forms a basis. Actually, there forms 2 bases, and they are orthogonal perpendicular to each other. These bases are also orthonormal, so you can do this. You will solve many systems of equations and write data compression algorithms like gzip, zip, ARA, and other compression algorithms. That was irony. I'm joking. So this is what an MSc in computer science would learn. Hi, good morning. I just started. No one is here to frighten you today. Great. So I just told that I will talk about single value, single vectors. So that was orthogonal matrices, and the orthogonal diagonalization of these matrices forms 2 orthonormal bases which are orthogonal, I mean perpendicular to each other. The generalization of orthogonal diagonalization, that is what we will make, and instead of eigenvalues, we will use singular values, and the starter decomposition is replaced by singular value decomposition. The problem is the following: you never heard from me spectral decomposition because no one told me that it is necessary. It was not in the syllabus. Doesn't matter. You will do and understand without it. So this SVD is a singular value decomposition. It means after the LU and QR decomposition of a matrix, we will do something new, a third type of decomposition. Okay, this matrix mapping are functions, and what I want want to tell you is there are two systems of orthonormal bases which are perpendicular to each other. This was true for Arad n, real matrices, and complex vectors and matrices you can do the same. With horrible price, of course, so it's not easy. Oh, important thing. I talk about this right now. We spend the time, we have fun, but I will not ask in the exam, and I will not ask this in the midterm test. It would be not fair to ask this because well, even for a physicist, I don't know what they do it. Next year, the next students will not learn this. I will change the syllabus. But now I haven't had time and I use the original one. Okay.
Will you give us again the example?
Sorry?
Are you going to give us the example of the...
Yes, as soon as possible. I wanted to do it this Monday. But finally, I was happy to prepare for the lectures and everything yesterday. I will do it during the spring holiday. Not tomorrow, but somewhere. During the spring holiday, I was quite silly and clumsy, so I accepted to be a member of the jury for a scientific student conference. There is an organization for you. I talk about it. You can go to, and everyone else, you can go for a professor, for a tutor, and you can ask a topic and you can do research as a student. And every second year there is this conference in different cities of Hungary. Last time it was in Veszprém, in north from the Lake Balaton. This year is today. Is in this city, not today, next week. And next week there will be two sessions. One is for medical students at this that direction, and one is for math, geography, and physics students. It's very good. They have written a study. The study is quite simple if you compare with the real research, but it's a research. Usually the result could be published, and then they had to defend at their university or faculty. And then, if the quality was enough, then they sent to the national level. That is next week, and then they improve a little bit the study. Then they have to present, they have to defend, and then the jury gives points, and then there is some prize medals, and it's good for applying, good for admission to MSc or PhD or whatever you want. The publication is also good, and that's a fun thing because there are programs, there are nice lectures, excursions, cycle tour or sightseeing. Also there are banquets and a lot of things. That's this thing. That's a typical Hungarian thing. I never heard about it. But at American universities, it's automatically a graduate student can go to a department and do some research if he or she has time. We have a lot of interesting things for talented students. Just the energy and the money is not available for it, but still, because some people like it, still it exists. Okay. Additional things, and this is not the topic of the lecture. In Hungary, the level of the education, the level of the medical care is proportional to the size of the city. So everything is best in Budapest, then a large city like here, that's fine, and small cities, that's not the best. In villages, you can die. So I think it's a natural process. So the government each government should do anything about it. In Finland, for example, everyone moved to south, but they need one center in Oulu. It's almost at the Arctic Circle, and it's a big city. 300,000 people lives there. They have a good university. They have good industry. They have good IT industry. Lot of things, but it's artificial because people would escape to south. They have to give higher salaries and everything. Doesn't matter. I know the situation in Alaska, so it's something similar. But the climate in Finland is milder than in Alaska because they have the Gulf current.
I lived in Alaska for 5 years.
So, really?
Yes.
And did you enjoy it?
Yes. I was younger, I was little.
But you are close actually because you are from Washington. Well, are you from Seattle or near Seattle?
No, the other side of the state is where.
Okay.
Yes.
Yeah. Okay. It was a joke when I was at NASA. And I told someone I have to go to Washington. Oh, really? To Washington State? I'm in DC. So it's, but I didn't understand. They had to escape. That's the joke. Okay, so. Okay. Okay, we have a matrix. This matrix is not a square matrix, it's a general matrix. And it has two orthonormal bases. And the matrix becomes diagonal in these bases. Something is missing, and you should scream or cry. Because everything that we learned was about diagonalization, and orthonormalization was about square matrices. But that's fine. And also the eigenvalue program was for square matrices. But that's general stuff. So we are looking for orthogonal vectors, and in this orthonormal bases, two bases, the matrix became diagonal, and we are looking for a special function between this. Oh, there's a mistake. Doesn't matter. I will. Okay, there is a statement. If you have two vectors in Aradan, and if one of them is eigenvector of the A matrix transpose multiplied originally A matrix, then the AX and AY vectors are also orthogonal. No proof. You can check in the notes, which is in Hungarian, but well, this is funny actually, or hilarious is a better term. I told you that I gave you many suggested books and notes in English, but they not cover the syllabus. Okay, this A function or mapping is a function between the rows of the matrix no, the function between the basis which corresponds the rows of the matrix and the orthogonal or perpendicular other basis. And the common dimension is the rank. It also, I missed some statement. Okay. You have this A transpose A matrix and symmetric and positive semi-definite. Positive semi-definite was declared last year, and then it's orthogonally, you can do the dual resolution orthogonally, and the eigenvalues are non-negative. The eigenvectors makes an orthogonal basis, and also there is a second one. Doesn't matter. So the dimension of this is the same. Here also missing many statements. Okay, doesn't matter. Singular value. You have a general matrix in its real, the element are real, it n times n matrix. The rank is R. The square roots of the positive eigenvalues are of the A transpose multiplied A matrix are called singular values of A. The eigenvalues are these sigma 1, 2, 1 R. The singular vector is the appropriate eigenvalue. Okay. The name of singularity, this came from not from the black holes, but something something close. We learned about singular matrices. There are regular matrices. The regular matrix has a determinant that is non-zero. Singular matrices are has the determinant with zero. And this is this is for solving systems of linear equations where the coefficient matrix is singular. This is quite interesting also. There are cases when you have to deal with this. I'm pretty sure in tensor analysis and general relativity theory it's very useful. Does anyone work in general relativity theory? That's a joke. It's an interesting situation. I think next year I will reorganize everything and I will give more examples and more practice or something like this. So it doesn't matter. Now I talk about this. Okay, blah blah blah. Interesting. You can do something. You can replace the transpose or the transponent for conjugate transpose. And you can use this Hermitian or Hermitian conjugation. Yes, Okay. So if no one understands, we can proceed. This is what one teacher of me always told me in the secondary school, but it was a joke. But I'm afraid this is the situation right now. Okay. So we have this matrix, and we should determine the singular values, and you and we are looking for the orthogonal basis on the right and left side. Oh, so what we are doing right now is a very, very advanced decomposition of a matrix, which is useful in numerical analysis. If someone is dealing with numerical analysis in such high level, I guess you will, otherwise it wouldn't be in the syllabus. Oops. Not bad. That's not a good start. It's discharged. Ah. Does anyone else prepare new presentations? Yes?
Yeah. Election? No. Is it videotape? No. Like presentation is like it. Oh, no, it's saying the video. Video.
No video. I'm pretty sure no video. That's my specialty. Oh. Okay, great. Okay, so still working. Great. So we have this matrix, and must be vague and do this singular value decomposition. This is a matrix. And this is horrible pen. So first, we have to calculate the A transpose A. That is great, thank you. Other side. Yes. Okay, so I have satanic number 666. Oh my God, what's this? Okay. Could you please calculate me the square of 111?
12,321.
12,321. That's it. Okay? Could you please add 16?
$12,337.
And multiply with 169.
Divide.
Divide. No multiply, divide. Yes, thanks.
73.
My calculator is there.
73.
How many?
73.
73. That one. Great. Okay, so that's nice. That's why it is so weird. Okay, so this one is minus 420. Could you please divide minus 420 by 13? I guess that will be minus.
We got negative 468.
You got
Negative 468. Not negative 468.
you are right. It's and that's much simpler. So that's 468, and that's
Negative 36.
okay. Great. And the next two, it's 642 divided by 13.
I think it's, instead of 666, I think it's 444.
Wait, what is it? It is 4.
I think it's negative 444 divided by 3.
Ah, yes, thanks. You are right. You are right. See?
And then it's negative 36 at the final.
And that's Yeah, then we know this. Okay. And this one is yeah. Yes. Okay. So to do this singular, to calculate these singular values and vectors, we have the appropriate what is it vector, no matrix, and I have to calculate its eigenvalue. Well, great. So the eigenvalues are 21, 25, and 100. Great. However, the singular values are the square root of this. That's great. These are the eigenvalues. Aha. These are singular values. That's okay. This part is finished. Now I'm calculating the singular vectors. My God. Um, that's a rare number. Oh my God. Okay, that's perfectly wrong. That's very weird, so the coordinates are the opposite that I get. But I think I calculated well, so this should be the result, and not that one. Ah, no, it's the same. No, I think that's good. So this is wrong. The so these are the eigenvalues of that matrix, and we have these vectors, and these vectors are the left, no, right singular vectors, and the other very rare because this is Okay. So this U1 EV multiplied 1 per sigma is sigma times the vector. So this A U1 is A V1. That's okay. I'm perfectly lost. I will check this out. What's this? Something is very long with this. Doesn't matter. Sorry. Time's up, and just let me finish this. So there is this singular decomposition to you can do also diagonalization with these matrices, and this diagonalization is for semi-orthogonal matrices and a lot of things. There is a so-called reduced singular decomposition. You can do it, doesn't matter. Okay? Keep okay, you can do this decomposition. There are a lot of things that I wanted to keep, There is so-called principal component analysis. If you switch your profession and will be data scientist, then this is used to decrease the number of independent variables in a data set. There are a lot of things. It has an algorithm. You should know what is covariance. Do you know what is covariance? This is something, it says the dependence of two set of series. The principal component analysis has steps. You can check it here. And that's it. I will not ask this in the midterm test, and also I will write it in the topics, the definitions and the statements of the exam, but I will not ask it. Why? It's far beyond your scope. You are chemist, so you are chemist BSc, not PhD in physics or something like this, or data science. Either the quality of this lecture and practice is not suitable. I have some critics for myself. To teach this, I would need weeks. Thank you very much. Next time we will check next 2 weeks ago, 2 weeks later, what Gabor Lente gave me. So thank you very much. Enjoy your holiday. Enjoy the spring, or sometimes it's summer. It's great. Thank you.